So I recently got this Aware device, which is an air quality sensor that I placed in my bedroom, and it measures the temperature, humidity, CO2 levels, VOCs, and PM 2.5. Is that at a certain time every single night, we almost hit about 4,000 parts per million. And I'm a little concerned about having brain damage with not enough oxygen. So I Googled it, and it turns out that 2 to 5,000 is not good at all, and then 5,000 and up is really not good. So the problem is that we've moved into a brand new house that is super airtight because it's energy efficient, and so no air can get in or get out of the bedroom. So the easiest thing to do is just to air it out, open up the window, get some fresh air. But the problem with that is that the entire West Coast is on fire all summer. You can see this just around me right now. There's probably a couple hundred fires burning. And the last thing I want to do is hotbox the entire bedroom all night long. So that's just not really an option. So I decided to pray and see what happens. And of course, God delivered, and his friend Node Red also decided to help me out. So what I did is I set up this workflow, super easy workflow, 13 steps, not much to it. First thing we want to do is check if it's raining. So just have an API that goes out, checks if it's raining, and reports back yes or no. Next, we want to see how good or bad the air outside is. So we do an API call to the purple air sensor that's near our location, and we get all the data back about the air quality that's outside. And finally, we do an API call to the Aware on our local network to get all the data about the air quality inside of the bedroom. And finally, we have a really simple function that takes all of this data and figures out if the window should open or if the window should close. And if it opens, then this is what we get. The window opener automatically opens it up and closes it whenever it needs to open and close. And in this video, it's going a little slower than usual, but that's because this one is in the bedroom and it's dead quiet. It also has a safety feature where if something gets in the way, you can see my fingers there are in the way, it'll automatically stop and then save its position so it knows where it's at. Here you can see that it takes just 7 pounds, and you can actually dial this down to about 4 pounds in order to stop it from moving. So if the window is locked, it'll actually also detect that lock and stop on its own. If there's ever an emergency, the whole thing just pops off in about a second, and there's just 2 of those mounts, and you can see that it pops right back on. Using an adhesive, you put that window mount on, and then you put that sill mount on, and it's all adhesive. There's absolutely no holes or screws. In order to hide the electrical a little bit better, what I've done is I'm using a 22x2 security wire connected to this barrel plug adapter, and this just allows that wire to be made as long as you need it, and you can kind of tuck it away wherever it needs to be tucked away, and you can't see any sort of wire running to your window whatsoever. This is actually the second version of the window opener. The new version is at the top there, the old version is at the bottom, and this is kind of showing you how much more compact the new design is, and I've actually removed a few things as well, and now everything is just super compact and fits a lot better. The motor's also completely changed. In order to remove a lot of the complexity and issues that I had with the geared motor, I just went with a bigger NEMA 17 and then ran more current through it. Now we also have 2 limit switches, Hall effect sensors, one on each side, and that's how it detects if the window is open or closed all the way. And here's the window opener one more time. If you have absolutely any questions related to any part of this project, I am more than happy to answer them. And thanks again, and I'll see you in the next one.